Welcome to this course. It's amazing to have you on board as a student. Now in this course, you will learn all about the MERN stack. You will learn how to build amazing full-stack web applications with MongoDB, Express, ReactJS and NodeJS. And you will learn all of that not just in theory, but actually apply it in practice to a real course project, which we will build from scratch. A project that shows you how these pieces work together and which will also include important topics like file upload and user authentication. So that by the end of the course, you will be able to build your own full-stack web applications with these technologies. Now that's the course, but who am I? My name is Max and I will be one of your instructors in this course. I will be responsible for the parts about React, Node, Express and how we combine all these things, including authentication. But in this course, I'm joined by Manuel, a MongoDB expert who will be your instructor and guide in the database-related sections.
Hi, I'm Manuel, I'm a data scientist and MongoDB expert. Now you know what this course is all about, but what are the course requirements? What do you have to bring to the table to succeed in this course? In this course, you will learn how to connect Node, Express, MongoDB and React. And the connection is the core focus of this course. Therefore, this course does not dive deeply into each of these technologies. The course comes with refreshers on React, MongoDB and Node, but the refreshers are, well, refreshers. If you really want to dive deeper here, make sure to check out dedicated courses on these topics. But for this course, basic ReactJS knowledge is highly recommended, and also basic knowledge of Node.js helps a lot to succeed here. These are the core requirements of this course, and with that, it's now time to dive into the course.
So what's MERN? What does MERN stand for? The M stands for MongoDB, and that is a database solution. The E stands for Express. I'll come back to what this is in a second. The R stands for ReactJS, and this is a browser-side JavaScript library that helps us build amazing user interfaces. And the N stands for Node.js. This is a server-side JavaScript runtime, an environment where JavaScript code can be executed outside of the browser. And now ExpressJS is a framework for Node.js, so it in the end makes building Node.js applications easier. Now combined, these technologies form the so-called MERN stack. They work together particularly well, and you can build amazing full-stack web applications with these four technologies working together. So let's take a closer look at each of these technologies to understand which role it plays exactly in that tech stack. So what's React? React is a client-side, so on the browser, library which allows you to build highly reactive user interfaces. So it's all about building user interfaces. With React, you write JavaScript code that will be executed in the browser. And since it runs there, it is responsible for controlling what the user sees on the screen and how things there change when a button is clicked, when something is entered into an input box. It's really all about that. It's about rendering a user interface with dynamic data and about updating it when data changes or when certain events occur. It's about handling user input and providing feedback to the user. And it's also, and that is where the other three technologies will come into play, it's also about communicating with backend services. And with backend, I mean services or technologies that don't run in the browser of your user. So React, so to say, is the front end. The other three technologies, Node, Express, and MongoDB, together make up the backend. Now we use libraries like React, and there are alternatives like Angular, with which you would have the MERN stack instead of the MERN stack, which do the same. But we use such technologies to provide users with a mobile app-like user experience, where everything happens instantly, where we have a great reactivity, where things on the user interface really feel great and instant, and we simply provide a really awesome and amazing user experience. Now what about the other technologies? What is Node exactly? It's a JavaScript runtime typically used or often used to create server-side JavaScript applications. Now, technically, that's not the only thing you can use it for, but it is one of the most prominent use cases and scenarios. You can use Node.js to execute JavaScript outside of the browser. And since it runs outside of the browser, you can, for example, use it to create a web server with it. So to run it on some machine which is exposed to the internet, which then accepts requests and sends back responses. So we can then use JavaScript as a server-side programming language, as an alternative to PHP, ASP.NET, Java, and so on, basically. With Node.js, we can listen to requests and send back responses. We can execute server-side logic, and we can also interact with databases and with files, things we typically don't do in the browser or we can't do in the browser. Since we're not tied to the browser anymore, there are certain things we can't do anymore. For example, interact with the DOM, because there is no DOM, it's running outside of the browser. But there are new things we can do. For example, well, write files or do things like this. And therefore, as I said, it's an alternative to other server-side programming languages. And just like those languages, it's also important to note that it's rarely used standalone. Instead, typically, we use it combined with Express. And Express is a Node.js framework, so we still write Node.js JavaScript code, but we get utility functions and a certain way of structuring and building our applications, so a certain rule set we adhere to basically, which makes building Node.js applications much, much easier. So it's based on Node.js, but gives us new functionalities. It's strictly middleware based, and you will learn what that means throughout the course, which means we have a clear way of handling requests, a clear funnel through which all requests are passed, where we then can extract data or prepare the response. And in general, with other features like routing, view rendering, and more, we got a lot of tools and clear rules that almost force us to write amazing and really well-working Node.js applications. So it really simplifies the usage of Node.js, and if you know PHP, it's a bit like what Laravel is for PHP, an amazing framework that simplifies the usage of the language. And that leaves us with MongoDB. What is MongoDB about? MongoDB is a NoSQL database engine which allows us to store documents in so-called collections instead of records in tables as we would have it in SQL. So it's a database engine. It's all about storing data. It's about storing our application data specifically. We use MongoDB in this course and in general to store, for example, our users, our products, or whatever our application is about. Unlike SQL, it doesn't enforce a schema for our data. We can still build one and use one if we want to, but we're not forced to. And we also don't need to work with relations. We can still set up kind of relations, but it's all a lot looser than it is in SQL. You're not forced to do these things. And this is the case on purpose, of course, because it also gives you many advantages. For example, NoSQL databases like MongoDB often give you amazing performance because they're way more flexible. It's also very easy to connect it to Node and Express, because as you will see throughout this course, writing queries against MongoDB is really straightforward and super easy when working with JavaScript anyways. So it's really fun and easy to use MongoDB in JavaScript applications. Now, for security reasons, as you will also learn throughout this course, we don't connect to MongoDB directly from inside our React application. Instead, we do that with the help of Node and Express, and that is how we then have all these technologies work together. So it's a powerful database which can easily be integrated into a Node Express environment. Technically, however, you could also swap MongoDB for other database engines. It wouldn't be the MERN stack anymore because, well, our M would be gone. But of course, you could also build an app with React, Node, Express, and some other database. But as I said, MongoDB really works well and is super easy to use. So we learned about the individual technologies. What's the big picture then? How do these things work together? Now we can differentiate between the front end and the back end if we want to, or client and server. What happens on the client is our front end. What happens on the server side is our back end. And on the client, we use JavaScript, or specifically ReactJS, to build an amazing user interface. On the server side, we use Node, Express, and MongoDB. Now we use JavaScript here for the presentation and the user interface. We will build a single page application with it, and I will come back to that later in the course. And on the server side, we have all our server-side business logic. We can store data persistently, either in files or in a database. We also implement our authentication logic there, for example. And technically on the server, we even can split NodeExpress from MongoDB, because as you will learn throughout the course, MongoDB will actually also run on its own server, its own machine, but it all happens outside of the browser, so I all consider this to be the backend. Now that of course leaves us with the question how client and server communicate, and that will happen with help of requests and responses, HTTP requests and responses, which are exchanged between these two ends. We will send background HTTP requests from inside our React JavaScript app to our server side, to our NodeExpress application, and this application will then reply with responses. And we will also exchange data, typically in the JSON format. This is how this will generally work together. This is how this will be connected. But we will have an entire theory module where we will take a closer look at this. And then, of course, we have a huge course project which we built from scratch, where we will build all these different areas, where we will build the front end and the back end and connect to a database and so on. And there you will, of course, also see all these things come together.
So this is the big picture, but what's inside this course now? We are almost done getting started, and in the next module we'll dive into the MERN in theory. So we'll have a look at all the 4 core components of the MERN stack: MongoDB, Express, React and Node.js. We'll see how these work and how they are connected to, well, finally build the MERN stack. With that theoretical part out of the way, it's time to dive into our course project then. We will start with the React frontend. For this, we'll use features like components, hooks, routing, and we'll also add front-end user input validation. And with that, towards the end of this module, we will have a nice looking and, from a front-end perspective, working application. What's missing here, of course, is the backend then. Here we'll focus onto Node and Express, we'll create our own REST API, implement our own routes, use controllers and models, and as we did it for the front-end, now it's time for the backend user input validation. Besides that, we'll also learn how we can connect our backend to a real database, MongoDB in our case here. With that, the backend will be finished. What's missing here, of course, now is the connection of these two ends, and that's what's going to happen in the next module. With that, we will have our first draft of the working MERN application here. Few things are missing though at this stage. One thing is file upload, covered in the next module. Here we will learn how we can store files, images in our case, on our own server. Following the file upload, we'll work on authentication. The authentication module will mainly cover the user sign-up and the user login logic, so that only if you are logged in, for example, you can access certain parts of our application. And with that, our application will be built. We will have a full MERN stack application at this stage. There is only one last thing missing, and this is the last module, which concludes the course, the deployment module, because up to this point, we were working in a local development environment. Here we will learn how we can deploy our app to a real server in the internet. So as you can see, lots of topics to cover in this course, lots of things to learn and to explore. And before we dive into the course now, let's have a look at how you can get the most out of this course. Our goal is that you get the best possible learning experience whilst following along this course. So how can you get the most out of it? Well, first, watch the videos. Sounds easy, it's an on-demand video course in the end, but it's important to watch the videos and to also watch the videos at your speed. You can adjust the playback speed in the Udemy video player, so make sure to use this feature to watch the course videos conveniently. Watching the videos is nice, but also code along. This is a very crucial part of the learning process. The whole course is interactive, so take the chance, code along, and important, pause and rewind. Don't just code along and don't understand what type of code you're writing and why you're writing it. In case something is unclear, pause and rewind, watch the lecture again until you really understand what you're doing here and why you're doing it. Besides coding along, practice is of course something that we highly recommend. Following along the course is great and you learn all the core things you need to create your own MERN stack applications in this course. But you should advance on your own, create your own projects, or enhance the course project according to your needs. These are all things that will help you in the long term. Practice, play around, and with that, become a MERN stack master. Now, on the way to become a master, debugging and searching is also something that will happen to you. Things can go wrong when writing code. This is also a crucial part of the learning process in the end. But it's important to have the right approach for debugging the code and for searching for solutions. For that, you can find the used code attached to the last lecture of each module in the course. So in case you're stuck, make sure to download this code and compare it to your code. You might have a tiny little mistake, and with that approach, you can quickly find it and continue with the course. Also, Google in case you have any kind of error message. Chances are that if you have this problem, another person had this problem too, and with that, a solution can be found quickly via Google. Besides Google, you can also use the integrated Udemy search function. That's also very helpful. With that, you can search through the course content, and you can also search through the Q&A section, because that's the last important step to make sure you get the most out of this course. Ask and answer questions. In case you're stuck and you can't continue, ask in the Q&A section of the course, and we'll do our best to help you as quick as possible. But in addition to asking, it's also important to answer questions, because answering is so much more rewarding. Asking is easy, right? But answering and helping others, this is really great, because nothing can go wrong here. If you give a wrong answer, somebody will correct you and you will learn. Or if you gave the right answer, you practiced your knowledge and the person who asked the question gets an answer. And that's basically a win-win situation for everyone. Now with that, you are well prepared for the course, and this means we can now dive into the course and continue with the MERN stack in theory now.
Now, in order to build an application with the MERN stack, we need to thoroughly understand how it works. So in this module, we'll dive a bit into MERN and how the different pieces work together in theory. Towards the end of this module, we'll also have a look at a simple MERN application, but of course throughout the course we'll then build a bigger one. But learning this theory and understanding the big picture is crucial. Specifically in this module, we will have a look at all the different pieces, React, Node, Express, and MongoDB, and understand how these pieces are connected or how these pieces are working together. Because of course that is in the end the essence of the MERN stack, that you understand how to combine all these technologies. You will also learn in this module that there is more than one way of combining these technologies, and therefore we'll have a look at those different approaches, and I'll explain the pros and cons of the different approaches and which approach we'll use in this course. And with that, let's dive right in and let's have a look at the big picture of the MERN stack and how that all works. MERN, of course, stands for MongoDB, Express, React, and Node. And we want to have these four technologies work together. We want to build a full stack web application where these four technologies are used because they tend to work together really well. But how do they work together? How are they connected? The R, React, is responsible for the client side, for the browser side, for what the user sees, so the presentation and the user interface. This means that we will use ReactJS to build our front-end facing web application, the thing that runs in the browser. ReactJS, as you should know, is of course based on JavaScript. It's a JavaScript library, and it's JavaScript that is executed in the browser. So React is used to build beautiful and highly reactive user interfaces in the browser. It's there to render something onto the screen and re-render it whenever something changes, update the user interface, and provide a great user experience to our end users. Put in other words, React is responsible for what the user sees in the end. React alone is great, and we can build stunning user interfaces with it. But of course, if we only work with React, we have some limitations. Most importantly, we're not really able to execute any logic on a server. So in a place where users can't see our code, they can see it in the browser. Anyone can use the browser dev tools to look into our code. And in addition to running code the user can't see or running more performance-intensive tasks, which we also don't want to do in the browser, In addition to that, we typically also want to store some data in a persistent storage, and the browser side is not such a persistent storage. Users can clear the data there. The browser might clear data on its own if it's running out of space, so data there is not persistent. It's also not shareable across all users of our web applications, because if we store data in the browser, of course it's only readable by that browser, so in the end by that user, and not of other users of our web application. For an online shop where users are able to create products which should be visible to any user, that would be bad. So that's why we need a so-called backend, a server side. This is a web application that runs on a dedicated machine, a server, somewhere in the internet, reachable by anyone, so opened up to incoming internet connections, and that server is created and run with the help of Node.js and a Node framework, ExpressJS. These two pieces are used to write JavaScript code that runs on a server, detached from our client, from our browser. There we can run any business logic which we might want to hide from our users, or which is more performance intensive. Since we run it on a dedicated machine, a dedicated server, we don't rely on the machine of our users, which is great. We also can use Node and Express for file storage, and we will in this course. And therefore, this is an important part of a real web application. Now, this server side and the client side, so the browser, communicate with requests and responses, HTTP requests and responses. Specifically, so-called AJAX, or as I like to call them, behind-the-scenes requests and responses. Requests and responses triggered from client-side JavaScript so that they are sent to the server and the response is handled in the client without reloading the page on the client. That is achieved by exchanging data, which is not a HTML page, which would be rendered by the browser and which would therefore lead to a page refresh, but instead which is in a so-called JSON format. There also are other formats you could use, and we'll have a look at one other format in this course, but JSON is by far the most common format for exchanging data. JSON stands for JavaScript Object Notation, and it's a machine-readable and also quite human-readable data format, which in the end is used to exchange text data, numeric data, and structured data in any form. This data is attached to both requests sent from the client to the server and responses received by the client incoming from the server to then re-render something on the client side, so using React to re-render parts of the UI, or to do something on the server side if the data is received there. For example, store it in a database. Now, speaking of that, the database, MongoDB, is missing in this picture. Now, that's our third building block, if you want to call it like this. We also have an extra database server which runs our MongoDB engine. And that's really important to understand. In the end of this picture, there are three big blocks working together. Two servers, one running our Node Express app and one running the database engine, and the client side. That's also involved, of course. Now, that database server can run on the same machine as our Node Express server or on a totally different machine. That doesn't really matter. The database server in MongoDB is then used for the persistent data storage. Not file storage. You should always store files on a file system, not in a database. But any other data, like the name of a product, the price of a product, the users of our web application, things like that would be stored in a database like MongoDB. Now, the important question, when we have a look at this incomplete picture here, is who's talking to the database server? And that is our Node Express application. That application sends database queries using the MongoDB SDK, or a MongoDB library to be precise, to that database server. We don't send requests from the client side directly to the database. Why? Because to send these queries, we need to include our database credentials, so the username and password to log into our database, so to say. As I mentioned earlier, all the code that runs on the client side, so in the browser, is readable by all your users. There is no way of disabling this. This is how the web works. So if that code would include the credentials for your database, your users could hack your database. They could gain access to it. So we do this on the server side where the code is not readable by our users. And from the client side, we just send requests and responses to the server. And on the server, we decide which requests we want to handle and which responses we want to send back. So we have full control on the server side, and the client is only able to communicate with the server within the request-response patterns we allow. And that is, of course, what we will build in detail throughout this course. This is the big picture for the MERN architecture. This is how all the pieces work together and which pieces are involved in the first place. And this architecture allows us to build amazing web applications, highly scalable and very fast web applications with a beautiful and highly reactive user interface powered by React attached to them. Now with that, let's take a closer look at some of these building blocks. Let's take a closer look at the front end, the client side, the browser side. I will use these terms interchangeably, by the way. And that, of course, is powered by React. Specifically there, we build a React SPA, a single-page application. Now, this simply means that React is in charge of re-rendering everything in the browser. Only one HTML page, that single page that makes up this term single-page application, is served from some server to the browser in the end, and thereafter React takes over. And whenever something needs to be drawn onto the screen, or whenever something needs to change on the screen or needs to be re-rendered, React will do that. For that, we'll also handle front-end or client-side routing with an extra library, React Router DOM, and this will help us render totally different React components. React is all about components. You will, by the way, also get a React refresher in one of the next modules. So the React router will help us render React components based on a path the user enters into the URL bar of the browser. So we will have the feeling of having multiple pages, but in the end it's all React and therefore JavaScript re-rendering significant parts of our page, so of what the user sees when we change the URL or when we get new data from the backend and so on. Now, in our React application, we also typically handle some front-end state. State in the end is data, you could say, that influences what is shown on the screen. And when our state changes, chances are that we want to re-render parts of the screen. React is all about managing such state, and it has built-in mechanisms to automatically re-render the parts of the screen that need to change when something changes. Now, for state management, we can use React State in class-based components. We can use hooks, a relatively kind of new feature in React, and or also for application-wide state, the Redux library. Now, as I mentioned, you will get a refresher on React later in the course, but I will not dive into every aspect of React. That would be enough for its own course, and indeed I do have such a standalone React course, which I strongly recommend that you have a look at before you dive into this course. Now, one other important part of your React application are, of course, all these components you build, because React is all about components, and how you style those. So the styling is also part of the front-end work or of the front-end application, that your application looks good. Now, as I mentioned, for the routing, we'll use React Router DOM, and there we can basically set up a route configuration and then define which React components are rendered for which path. We can implement state management with React hooks, with our custom hooks, which we'll also build throughout this course, and or with Redux. And for components and styling, we will build in this course some utility and UI components, though I will also say that throughout this course, I will also provide some finished UI components to you and some finished styles so that we don't spend the majority of the time of this course on writing basic button or input components and managing the style of these components, because that's really not the core of React and of this course, and therefore some finished components will be provided to you for this part. In general, of course, we'll build the entire React application from scratch though. And this is what React is about. It's all related to the front end, how we update it, and when things should change there. Now let's have a look at the backend. If we dig a bit deeper into the backend, of course we have to keep in mind what I explained earlier, that we have decoupled ends, which means we have the front end powered by React, with the backend powered by Node.Express. And then we also have the database server with MongoDB. Now, because of that decoupled ends thing, our backend is built as an API, which stands for Application Programming Interface. Now, the term API is not just related to web development or to Node.Express apps. API is a general programming term, and it describes things which expose certain entry points, you could say, which other things can use. For example, if you're building a third-party library that should do some user input validation, you might offer certain functions the application that uses your library can call in a certain way to use your library. So basically, any library you create needs clearly defined entry points and a way of using them so that other users who did not build your library can interact with it. And for our backend, it's basically the same. We build a Node.Express application which defines some entry points, some ways of communicating with it, and only these ways are supported thereafter. If some client which tries to talk to our backend, for example the React app later, wants to interact with some entry point we didn't define, it will get an error. This pattern is important because it allows us to keep control over our API and control which actions we want to do, which actions we don't want to perform, and what should happen on each action, as well as which data we need to perform each action. And when it comes to building such an API, of course we'll do that all step by step throughout this course. It's important to understand though that there are two major kinds of APIs which you can build when you build such a backend. You can build a REST API, where REST stands for Representational State Transfer, and you can build a GraphQL API. Now, both kinds of APIs can be built with any server-side language, not just with Node.js, but of course in this course we will use Node.js. And both kinds of APIs can do anything on the server. Store data in a database, validate user input, get data from a database, and so on. Now, they work differently when it comes to how requests are received or how requests which are sent to the API should be formatted. A REST API, which is by far the most common and used form of backend web API, uses a combination of different URLs or paths, which are the things after the domain, and HTTP verbs, which is this get, post, patch, delete thing you might have heard of, to build so-called endpoints which trigger different actions. And I'll show some examples and come back to that in a second. So for a REST API, it's the combination of the URL and the verb used for the request that defines what happens on the server. And when we build such a REST API, we define the combinations of URLs and verbs we want to support. And for unsupported combinations, an error will be sent back if a client tries to use it. For a GraphQL API, that's different. There we have one URL and one HTTP verb, typically a post request. So we have one endpoint, which then in turn, however, accepts query commands. So since this HTTP verb is a post request, when you build a GraphQL API, the body of the request contains a query expression that adheres to the GraphQL standard in the end, which describes the operation you want to perform. Still, on the server side, when you build such an API, you define which query commands you want to support. So you still don't support everything. But you don't work with different path-verb combinations, but instead with that query language to trigger different actions and so on. Now, in both scenarios, we execute code on the server, and in both scenarios, we don't directly talk to the database. GraphQL and query commands, that might all sound a bit like we're already talking to a database, but always keep in mind, from your React app, you always send requests to your NodeExpress app, no matter if that's built as a REST API or a GraphQL API. It just influences how the requests look like, what you send. But in both cases, you talk to your NodeExpress app. And that NodeExpress app will then do something based on the action which is triggered because of your path verb combination or because of your query command. And then it's your NodeExpress server which will talk to a database. So let's take a closer look at this REST and GraphQL thing. How do these APIs look like in detail? Well, as I mentioned, we still have that client-server combination, and the server uses NodeExpress, and then we talk to a MongoDB database from that NodeExpress server. The client, of course, uses React. Now, how does such a request look like, which we send to the NodeExpress server if that server is built as a REST API? Well, as I mentioned, it's a combination of a specific URL, or specifically the path, which is the thing after the domain, because the domain, of course, will always be the same. Yourpage.com, for example, is the domain. But the thing thereafter, /products, /nothing, /new, /user, whatever it is, that is the path. And that combined with a specific HTTP verb triggers a specific action, at least if we support that path verb combination on the server. For example, we could be sending a post request with the post HTTP verb to the /post URL, or a get request to /posts, or a get request to /posts/ and then some dynamic path segment, which NodeExpress also supports, so that we, for example, could have different IDs of posts which are parts of our incoming requests. These are our so-called API endpoints, and as I mentioned multiple times, it's up to us, the developer of the NodeExpress REST API, to decide which endpoints we want to support. And then upon getting a request on such an endpoint, we run some server-side logic to do whatever we want to do, for example, to reach out to the database and then store data there, get data from there, and so on. Now, when it comes to these HTTP methods, post and get might be methods or verbs you already know, but there's more than just get and post. Of course, we have get, which we typically use to get data or get a resource from the server. And we have post to post data to a server, so to send data there and then create new data, a new object, new resources on the server. But we got more than that. We also got put, which we typically use to create or override a resource, patch, which we use to update an existing resource on a server, delete to delete a resource, and also actually options, which we won't send on ourselves, but which the browser automatically attaches for certain requests, which the browser then uses to find out if the request we actually want to send is supported. I will come back to that later. Now, what's really important to understand here, because it's a common misconception, is that just because you send a post request, you don't actually store something in a database automatically. As I mentioned, it's up to you, the developer of the API, to decide what you want to do, which code you want to execute, for which verb path combination. And you typically want to map the verbs in a way that's logical. So you want to create data when a post request is received. You want to delete data when a delete request is received. But theoretically, you could also return data. So you could get data upon a delete request, or return data upon a put request, or return data upon a post request. That would just not be logical, and therefore you want to avoid it. But it's really important to understand that the verb path combination alone does not dictate what happens on the server. That is up to the logic you wrote there for the different verb path combinations. So that's REST. Now, what about GraphQL? When we have a look at that same picture for GraphQL, we have the same general logic, and that's important to understand. We send a request to the NodeExpress app then, but how does this look like now? As I mentioned, with GraphQL, there aren't multiple endpoints. There is one single endpoint, and that typically is a post request on some path of your choice often the path is /GraphQL, but that's not a must use. Now, the trick here is that this request, since it's a post request, has a request body. And that request body contains a query expression written in a standardized GraphQL query language, which is then parsed by your NodeExpress server. And if you then wrote code to support that specific expression which was sent, you can then, well, use the data which is part of that expression and so on to store data or to get data and so on. The query, which could be in the post request body, typically looks something like this. We describe the operation we want to perform. Alternatives to query, which we typically use to get data, would be mutation to add or change data, or subscription to set up a live subscription. We then have an identifier of our choice, which we also could call endpoint therefore. And then the data we, for example, want to request or we want to send. Now, I do have a free series on how to build basically a simple MERN application with a GraphQL backend, and attached you find a link where you learn how to build such a GraphQL backend from scratch. So that might also be interesting for you if you want to learn more about GraphQL. In this course, when we compare REST to GraphQL, we will go with REST, and here's why. The REST API approach uses this path HTTP method combination to identify resources or actions on a server, and that's very intuitive and very easy to learn. Such an API is stateless and decoupled from any frontend, which means a REST API you build cannot just be used with your React single-page application. Any client could talk to it. So if you later build a mobile application with iOS or Android, you could talk to that same API because the API is totally separated from the frontend, which is the cool thing about this API approach. You can reuse the API and just attach different frontends. One of the reasons why such APIs are so popular these days. Now, we will use the REST API in this course because it's the most common type of API. You see a lot of APIs built in that way out there in the wild, because it's easy to use, easy to learn, easy to document, and very intuitive in the end. Now, a GraphQL API does not use the path HTTP method as you learned, but instead such a query expression using a certain query language to identify a resource in action. And just like the REST API, it's also stateless and decoupled. So just as with the REST API, you can attach any client to that API, which is great. But the reason why we won't use it is that despite GraphQL being very popular and very useful and powerful, you need to learn that extra query language, which is some extra effort, which not everyone wants to do. In addition, out there in the wild, you see way more REST APIs than GraphQL APIs, so I find it more important to learn that. Nonetheless, as I mentioned, attached you find a link to a free series I created in the past, where we also built a GraphQL API, and actually also a NodeExpress and React application that works with it, for free in a complete series. So this might be interesting to you if you want to learn more about that. In this course, we'll build a REST API from scratch because it is so important and so powerful, and we will build it from the ground up so that you definitely learn everything that's to it. And with that, we're almost done with the theory. Now there's just one more thing left, and that is related to how we host our different parts. You know from the big picture that we have three big blocks: the React app, the NodeExpress app, and the MongoDB database and the server that database runs on. Now the question is, where are the different pieces served from? Now we got two main options here. We can have one server, one computer, which hosts both our Node API and the React single-page application under the same domain. So mypage.com/nothing might return our single-page application, and then under mypage.com/API, we might have the endpoints for that single-page application to talk to. The alternative is that we have two separated servers. One very simple server, which simply serves our single ReactJS application HTML page and all the JavaScript files that application needs, and one server which hosts our API. So, If we take a closer look, for the left case that we have one single server, we have a NodeExpress API which handles incoming requests on that server. For example, under /API, any requests targeting these paths might reach our API. And requests which are not targeting our API routes would return the React single page application in the end. So these requests would get us the single HTML file and the associated JavaScript files that are required to run the React app. Between the React app and the Node API, even though they're running on the same server, we have that separation you learned about. So they don't really know much about each other than that they run on the same server. Data is still exchanged with these AJAX background requests in JSON format. If we have the two separated servers, then we really have two different machines. One which has our Node API on it, our NodeExpress API, and one which is served from that very simple so-called static host. Static because it will be a server which doesn't need to execute any server-side code, because it is a server that doesn't run any Node or any other programming language application on it. Instead, it's just a server which returns our HTML file and the JavaScript files and the CSS files and so on. So therefore, we got our two ends served on different servers, and data is exchanged in JSON format when we send these background HTTP requests. So that's always the same. In one case, they're just served from the same machine, in the other case, from two machines. In both cases, we got these logically separated apps. Now, regarding the MongoDB database, that always has its own database server, but just like the Node server and the React app, this server could be installed on the same physical machine as our Node and maybe all the React app runs on, or on a separate machine. And often you want to use different machines here to make sure that just because you're getting a lot of requests, you're not slowing down on your database requests or database queries, and the other way around. So therefore, separating the NodeExpress app and the database server onto two different machines is a good idea. Technically, you could run everything on the same machine. You'll always have the same logical separation though. Now actually, there also is a third way, which I really don't want to talk too much about though. You could have your NodeExpress server and not build a REST or GraphQL API there, but instead render HTML pages on the fly on that server with templating engines like EJS or Pug. If you took my Node.js The Complete Guide course, you'll learn about this approach as well. Now, you therefore really render different HTML pages for different requests on the server, and that rendered HTML code is returned. Now, to get React into the equation, you could have some parts of these pre-rendered HTML pages which are controlled by React in a widget-like way. So React only controls parts of the page instead of the entire page. This is possible, but it takes away from the great, highly reactive user experience we can build with single-page applications. Since we create and return HTML pages from the server for everything the user does, we constantly reload pages, we add a slight delay, and we don't have that highly reactive mobile app-like feeling we can achieve with single-page applications. Therefore, this is not the approach we will use here. Technically, of course, though, you could build an application with the same technologies, MongoDB, Express, React, and Node, so MERN, with this approach. But you would not get the same great user experience, and therefore, typically, when we talk about MERN, we talk about the logically separated ends, no matter if they're served by the same physical machine or not. We don't really talk about this approach. Well, and with that all out of the way, let's have a look at a very simple first MERN application so that you can see the big picture also in code, before we then dive into the different course modules where we will get a refresher on React, NodeExpress, and MongoDB, and then more importantly, build the different building blocks of our course project, which is such a MERN app, and then also connect these building blocks. So let's see that big picture, or at least parts of it, because MongoDB requires this extra database server setup, which we'll tackle in a separate module. But let's see this part at least, the React and NodeExpress API communication part, in action in a simple application. And no worries, this is just a short demo application. We'll build one, a way bigger one, the course project, from the ground up throughout the rest of this course. Attached, you find a zip folder, which you can unzip, and in there you'll find a front-end and a back-end folder. Now, combined, this makes up your MERN application, and this is a very simple dummy application which I prepared for you. The front-end holds a React application. The front-end folder here was created, or this project here was created with Create React App, which is a tool by the React team to create React projects. And it holds a React application with some components, because React is all about components, as you will also learn again in the React refresher in a separate module. For now, you can just take it for granted. So we'll have the different components, the building blocks of our front-end user interface, so to say. And with the backend folder with exactly one core file, server.js. Now, to run these ends here, you need to install NodeJS. You can install it from nodejs.org, and there simply download the latest version, 13 in my case, but that of course will change over time. Does not really affect the way Node works or looks like, however. And simply download that latest version and walk through the installer you get there. The default settings are fine, and this will install Node.js, so this special JavaScript runtime, onto your machine. It will also install one other tool onto your machine, and that's npm, the Node Package Manager. This is a tool which is required anyways to install the various dependencies, so third-party libraries we use, in both our backend code as well as our frontend code. Because even though the frontend code is not run by Node.js, it still will use third-party libraries, which are then simply used by the browser, or, also an important part, by our build setup, our development setup, where we have a dummy server that serves our front end, which reloads the page whenever we change something, which optimizes our code, and so on. These are all steps which are not run once we deploy our finished front end, but which help us during development, and for that we also need third-party libraries, and actually also the Node runtime, which runs this entire front-end build process. So we definitely need Node.js to do anything here. Now, you also see I opened this project here in an IDE, in an integrated development environment. This is Visual Studio Code, a great free-to-use IDE you can find if you Google for VS Code, in which you can then install from the page you get to, code.visualstudio.com. It's free and available for all operating systems, so simply download it and walk through the installer if you want to use that same IDE here as I do. Now, in that IDE here, I also installed some so-called extensions. You can get to the extensions menu with View Extensions, and there specifically the extensions I recommend that you install are the Material Icon theme to make sure your file icons look like mine if you like that look. Path IntelliSense, which can help you with auto-completion of file names. Prettier, which helps you with auto-formatting your code so that it is easy to read and you don't have to format it manually. And with all that installed, also if you go back to the Explorer or use the shortcut you see here, I also recommend that you look into the themes you got configured. Under Code, Preferences, Color Theme, there you can switch it to a different theme. I'm using the Dark Plus default dark theme here, which gives me the look you see here. You also here see the file icons I got from the Material Icon theme. Last but not least, I already talked about Prettier and that auto formatting. You can always check out your keyboard shortcuts, and there specifically the Format Document shortcut is one you should bind, because that will help you use that Prettier extension to automatically reformat your code. But with that, that's basically the setup I have here. Then I opened that extracted folder, which holds the backend and frontend folder, and I'm now ready to go. Well, or almost. First of all, as I mentioned, every end has some packages, some dependencies it uses. You find those in the package.json file, which is your project management file, you could say. And you see that I treat backend and frontend as separated projects, because they are logically separated. Now you see here for the backend in the package.json file, I got 3 dependencies, 3 third-party libraries this project uses. For the frontend, for the React application, I got these 3 dependencies. React, the library we use, React DOM, which is also part of React, and React scripts, which in the end helps us with our build setup and with this dummy server that serves the React application and so on. Now, to install these dependencies, you need to open up your terminal or command prompt, and you can use the one integrated into your IDE. You can go to terminal, new terminal here to open it, and then navigate into your frontend folder, and in there run npm install. And this uses the npm tool which was installed together with Node.js to install all the dependencies which are mentioned in the package.json file. It will then create such a node modules folder where these dependencies and their dependencies are actually stored in. Now, doing this just for the frontend alone is not enough, so I will open a second terminal and also navigate into the backend folder, because there I also want to install all the dependencies so that for both the frontend and the backend we got that installed. So let's wait for this installation process to finish, and thereafter let's start our 2 servers and see how they communicate with each other. So the installation of all the dependencies in both the frontend and backend folder finished, and now let's simply see what we got there before we have a look at the code. Now keep in mind, we have 2 logically separated ends here, and here, during development at least, we will also have 2 separated servers. Now, of course, both runs on our machine here, on our computer. But actually, we will run these 2 different ends under 2 different domains. Now, let's see what we got here. In the frontend folder, you can run npm start to start a development server that's part of the setup, basically added by this React scripts dependency, which will host your React application, this React single page application. So it's a development server which in the end hosts this single index.html file, which you find in the public folder there, which then in turn will import all the scripts it needs and launch your React app. You find that application, it should open up automatically actually, under localhost :3000. Localhost might look strange, but this is your domain. It's available on your local machine. It's a special domain there. And :3000 is the port on which we're visiting this. And combined, this actually is a domain as it would be the case for yourpage.com. So this combined is the actual domain. And if you would visit another page on, let's say, localhost 5000, that might look very similar, but it would actually be a totally different domain, as if it were served by a totally different machine. So here React automatically runs on localhost 3000, and that's our React single page application. Now let's go to the backend folder, and there you can also run npm start. Now here nothing opens up automatically, but you will see that you're now in a process which doesn't stop. So you can't enter a new command. By the way, it's the same for the frontend. That is the default, and that is what should be the case, because that means you have a running server. You can always stop these processes by hitting Ctrl-C on your keyboard, but then, of course, the server will be down. So as long as you're developing, you should have it up and running. So we got these 2 running servers. And the Node backend server here actually will run under localhost 5000. However, if you enter that, you will not see anything because this specific endpoint /nothing is not supported. Remember when I said that you as a developer decide which endpoints you want to support and you want to execute code on? Well, that's not one of them. Things change if you enter /products there, however. You see now you get back in the end a JavaScript object. This is actually this JSON notation I was talking about, which holds a products key and then an empty array. So here we seem to get back some data, even though it's empty, and that already looks quite promising. And now really keep in mind, localhost 5000 is a totally different server than localhost 3000. Now, obviously here we have some communication problems. With your Node server up and running, however, reload the React app on localhost 3000, and you will see that the loading part goes away, and instead we see could not find any products. Now let's add a book here for, let's say, $12.99 and click Add Product. What you see is it now appears down there. Now that's nice. But what you will also see, if you reload now and you keep both servers up and running in between, you still get that. You see loading for a fraction of a second, and then you see a book here. So it looks like the book we created here really was stored somewhere, was stored on our backend server. And when we reload the React app, we're fetching data from that server. And since the server runs on its own domain, but technically, of course, on the same machine as our front end, that request is super, super fast, which is why we see that loading text only for the fraction of a second, if we see it at all. But the really important thing here is that we are storing data on our backend, so on the NodeExpress app or with help of the NodeExpress app, and we're fetching it from there. Now that's how it works. Let's now have a look at the code to get a rough understanding of what's working together there. Now I want to start with the backend for that. Let's have a look at the server.js file. This is, in the end, our NodeExpress server. And one important thing about Node and Express is that, unlike with, for example, PHP, when you're building a Node application, you launch the server itself with Node.js. With PHP, you need some extra software like Apache to launch a server, which then runs and interprets your PHP scripts. With Node, you use Node itself to launch that server. So the server.js file has all the logic it needs to run the server, but also then to handle incoming requests. Now, we'll dive a bit deeper into how Node and Express works in a standalone refresher module. So I don't want to lose too much time on that right now. In the end, what you'll just see at the end here is that we have some listen method, which we call, which in the end will start your server and listen on port 5000. So this is also where you could change the port, but not all ports will work. Some are not allowed by your system. And for example, 3000 is not allowed because that's where our React app runs already. So you should leave that at 5000. And in addition, besides some other setup, you will see an app get and an app post method. This registers so-called middleware for certain paths. So here you see that path thing for certain HTTP methods, namely here a get method and a post method. So here you see that method path combination thing I was talking about. And then some functions that should be executed when a request reaches such a method path combination. And then here in the end, I sent back a response with some products. Here I create a new product. I validate the user input before we do anything else. And then I create the product, create a unique ID with some third-party library, add it here to this dummy products thing I will have a look at in a second, and then send back a response upon successfully creating that product. This is our core backend logic. Now, what we're not doing here is talk to a database, because for that we need to set up a separate MongoDB server, which is a bit more work, not horrible, but a bit more work, and therefore we will do that in a separate module. But what we do have here with dummy products is a dummy JavaScript array. This, however, is only stored in memory of this running Node application, which means whenever we restart the server, which we can do by quitting our Node server with Ctrl+C and then rerunning npm start, all that data will be lost. So after restarting that server, if we reload the React app, you see it doesn't find any products anymore, because as I mentioned, this is only stored in memory of the Node app, which of course is not a great storage. It's just a dummy storage here. Later, we'll of course store data in a database. You will also see this strange thing. I will come back to that later. That is important to allow communication between our frontend, which runs on a different server than our backend. But again, I will explain in detail why we need this and what this does later in the course. Well, and that's already it for our backend. You might not understand everything here, but again, we'll have a refresher on NodeExpress later. But it should be relatively clear that these are our endpoints and that this is where our main logic happens on the backend. Now let's have a look at the frontend. There we have a React application, and React applications are all about components. Components can be functions or JavaScript classes, and in this course I will use only functional components. In my React the Complete Guide course, you'll learn about both though. So there you can learn more about React components and different ways of building them. Now here in the front-end folder, you see that index.js file. This is in the end the entry point for our front-end application. This is where we render our React app, which is imported from the app.js file. So let's maybe have a look at that. Here, this is the JSX code. By the way, if you've never seen this before, this looks like HTML. It's HTML in JavaScript, an invention by React in the end. It's called JSX, and it is transpiled to valid JavaScript by the build setup, which we use behind the scenes here with our npm start process in the front end. This is simply a special syntax which allows us to write code which is translated to instructions that should insert or remove elements in the DOM in a highly readable way to us developers. So here what I get is I'm rendering a couple of React components, header, new product, product list. These are all React components. And also some default HTML elements like main and paragraph based on certain conditions, for example, if we're currently loading or not, and I'm passing some data to my components. Now these components are all imported here at the top, and you can find them in their separate files. For example, a button component, which wraps the native HTML button and adds some extra styling. The input component, which combines a label and input element and adds extra styling and behavior. The header component, which looks like this, and some product-specific components. For example, our new product form here, our product list, and a single product item. This together is responsible for getting onto the screen what you saw there. And in case that's totally new, besides that React the Complete Guide course I would recommend to you, you will also get that brief refresher I also already mentioned multiple times. Now in app.js, we also got more than just our components which are rendered. We also got some front-end logic, so logic that decides what should be shown on the screen and which also is responsible for sending these background HTTP requests to our, backend, which is our Node.js Express server. Now you see that logic here in the app function in this app component, and there I use a feature called React hooks. These are special functions provided by the React library, which help us with managing state, which is data that when it changes leads to a re-render cycle of the component, so which basically tells React to update the real DOM if the data changes. And we also use the useEffect hook. This is in the end a hook which allows us to run some code when certain pieces of data change. And here specifically I configured it to run when our application launches, and only then. Now here in this when the application launches code, I in the end reach out to the backend. The fetch API is a native JavaScript API built into browsers. I send a request to this backend URL here. It automatically is a GET request, and this is a combination which is supported there, get to /products. As you can see in the backend code, triggers this function. And then I expect to get back an object which has a products array, which I indeed do send back here on the backend. And I extract that response, then access this products key and set my loaded products, so this loaded products state data, to the data I got from the backend. And as I mentioned, this state data is special. When it changes, React will re-render the UI, which is the reason why when this loading finished, it swaps this loading keyword here for either our products or this fallback text. I also got the add product handler function, a function in a function, which is totally fine in JavaScript. It is supported in JavaScript without any special tricks. And in this add product handler here, I in the end build a product object and then also send this to the backend, but to a different URL /product and also with a different HTTP method. The default one is get, but here I override the default to set it to post. And post to /product, that is also supported on the backend, and it triggers this function here. Now there I attach my data, and send some extra headers to let the backend know that I'm sending JSON data. This is a helper method available in JavaScript to create JSON data. I check if the response is okay. Otherwise, in the end, I will show an alert. For example, if invalid data was entered in the inputs. And if everything is fine and we stored our data in the backend, I update the products I work with on the front end to re-render the UI and reflect that newly added product. This is what happens here. Now again, more detailed refreshers on the ends will be provided later, but I hope that with that this big picture is clear in general. Now, as I mentioned multiple times, we'll build a complete app throughout this course from scratch. You just get this finished app here. Later, we will build it from scratch, no worries. And therefore, then you will learn how these pieces are built and how they work together. But the general structure should already be clear right now with that big picture here. So we got a basic idea of how the MERN stack works and how the different pieces work together. As I mentioned throughout this course, you will not only get refreshers about the individual building blocks, but most importantly, we'll build an entire application where you can see all these pieces built out individually and then come together when we connect all the different blocks with each other. Now, this project which we're going to build is a project we of course have to plan before we dive into it. So in this module, I want to plan a React, or specifically the entire MERN project with you, because this hopefully also helps you approach your next project and get an idea of what you might want to keep in mind, what you have to think about before you get started, and how you can create a plan for the thing you're trying to build. Now, for that, there are a couple of general planning steps through which we'll walk in this module, so that by the end of the module, we have a clear plan of what we want to build and how we want to build it. The first step for that, of course, is that you need an idea. You want to solve some problem. That often or typically will not be a step you have to think about and specifically dive into, because more often than not, you will have an idea and then you want to start planning an app that solves the problem or that works on that idea. So this is only a rough first step, which typically can already be checked off the list by the time you're getting started. So the next step, the real first step after you have an idea, you want to solve a problem, is that you create a design. You sketch out the application you want to build. At least this is what I like to do if I'm building a front end. And that, by the way, is really important. The steps I'm giving you here are not the objectively correct steps you have to go through whatever you're trying to build. These are the steps that work for me. For you, the order might be different. Maybe you have some other step. Maybe you don't need a specific step. I'm really just sharing my personal approach here with you. So I got an idea and now I want to create a design. I want to sketch out the application. Now, when I talk about creating the design here, you could really work with design tools like Framer X or SketchUp or Photoshop and build your design there. Now, I'm not a designer and this is not a design course, so we're not going to do that here. Often, this is also a task you will probably outsource because chances are you want to focus on writing the code and you also are not a designer. Hence, here in this module, we'll just draw the general skeleton. We'll sketch out the application. We'll not really set up a specific design for this application here. Of course, we want to make sure it looks nice, but that's something we'll do when we implement it. I already prepared some nice styles and colors for you there. So once we got the general skeleton, we sketched out the general front end of this application, we of course also have to think about the data we work with, both in the front end, but also more importantly on the back end of our application. So we want to plan our data models, the data we or our app will work with. Which entities do we need and which data do we need to send across the wire from front end to back end, and then also from Node expressed to the database. This of course is a crucial part because that is a part that will affect all building blocks of your MERN application. Now, once the data model is clear and we got our front end sketched out, we of course have to plan our backend endpoints and the pages. You could put that into quotes because we don't really have more than one page, but the different components you could say you want to have on the front end in your single page application. These are the steps I want to go through together with you. We'll do it here in this module, and this is my rough planning process I go through whenever I approach a new project. Now, obviously, you can do way more work on all these steps. You can also come up with a complete design on your own. But as I mentioned, since this course is not primarily about designing and so on, I want to keep this module short and just give you a general idea of how this works. So let's dive into the first step, which is the idea which we need. Now, as I mentioned, often this is a step you can skip or which is skipped automatically because you already have a pretty clear idea of what you want to build and which problem you want to solve. In this course, I want to build an app with you where users can share places, their favorite places or any places they feel like are worth sharing, where each place has an image and a location and a title and so on with other users. So they can share it with other users. Or put in other words, if you're a user, a visitor in this application, you can view a list of users, you can click on a user, and then you see the places this user shared. The great thing about this app is that it's not too complex, and yet it has all the important pieces you want to have in such a demo app, which you will probably also need in the apps you're trying to build after this course. Specifically, we have all the core CRUD operations in there. So create, read, updating, and deleting will cover all of that. We'll be able to create users, create places, get users and get places, which is basically reading the data, update places, and delete places. So that's all in there, which is super important. In addition, we have more than one data model. We have users and places, and that helps us work with relationships as well. We also work with images, and hence we'll cover image upload, which is also a very important topic. And of course, we'll also validate user input to make sure that only valid data ends up in our database and on our backend in general. And last but not least, we'll have authentication and authorization in this course. The difference is that authentication means that users need to sign up or log in to work with some parts of our app. In this example, new places should only be creatable by logged in users. And authorization means that even if you are a logged in user, you're still not able to do everything. For example, in this app, updating or deleting places should not be possible for all authenticated users, but only for the users who created that place. So we got a lot of core important things in this app, which is why this makes for a great demo application for this course, and which is why this is my idea for the course project. So let's now have a look at the design sketching part. And as I mentioned, we'll not worry too much about the design when it comes to picking colors and so on. There, I will just provide you some colors I came up with in advance. Instead, here, I now want to focus on sketching out the front end of this application. So how this app should roughly feel, how the pages are connected, what should be visible on the user interface. For that, you can now have a look at my amazing drawing skills. Not, but I hope it will still be helpful. So what do we have in the front end of this application? Well, it all starts with the page we're visiting. And by the way, I'm drawing the desktop view here. We'll also build this application such that it looks and works great on mobile. But here I'm just sketching out the desktop view. So we'll start on some page where we probably want to have a header with some title of our application. So the name of the app, our brand, something like this. And then also some menu items on the other end of our header here. Now I'll come back to these menu items. Let's think about what we see on the starting screen. There, I want to have a list of users. So a couple of list items in the end, which simply are rendered beneath each other. where for every user we have like an image of that user, the name, like Max or Manu, and then the number of places of that user. So the number of places that user shared. So maybe here I shared 2 places and Manu shared 1 place, let's say. And of course we have more users here. So that's the starting screen. Now, when we tap a user, something should happen. Before we think about that though, let's talk about the menu items I want to have in the header. There, it depends on whether we are authenticated or not. If we are not authenticated, then here in the header, I want to have an authenticate option. Here I'll just name it auth. You could name it login. So basically an option which we can tap to be taken to the authentication screen. If we are authenticated, then here I want to have an option to create a new place. So to be taken to a screen where we can simply, well, create a new place. I also want to have an option which should always be available, and that's basically the users list. So this starting screen here, that should always be available no matter if we are logged in or not. We could also say that this option, when we tap this, is basically also happening if we tap the title, because that is our starting screen of the app. So these 2 options here are basically equivalent, we could say. I think that would be a setup which should generally work. But now let's see what happens when we tap a user here. So when we click our user here, like Manu, then I want to be taken to a new page. Now on that new page here, which is loaded, of course we have the same header as before with the title and with our different menu options here. I'm not going to write them out again. These are the same options as you see up there. So instead, let's focus on the main area of this page. What do we see there? Well, Manu has 1 place, right? He has 1 place. So here I expect to see that 1 place. If he had more places, then I would expect to see a list of these places here. Now, that place should have an image, and we'll see how exactly we create this. We could have the image at the top here, for example, then the title, and then also options that allow us to interact with that place. For example, we can have a view on map button here. The idea is that when we click this or when we tap on this option, we open up this place or the location of this place in a modal, so in an overlay to the screen, where we can see that place marked with the help of Google Maps. In addition, I want to have 2 other buttons on the right here, an edit and a delete button, which we only see if we are the creator of that place. So that's only visible if creator, so if Manu in this case, so if the logged in user who is viewing this screen is also the creator of that place. Otherwise, only the view on map button is visible. Now when we tap that view on map button, as I said, I want to open an overlay which has a map, so which uses Google Maps to display the place on the map with a marker. That's the idea. What should happen when we tap this view on map button. So this is roughly how that could look like. We might also add a description so that we have the title and description here, but that's my general idea. The idea is not that we can tap this place to be taken to a new screen where we then view all the details, but that we can see all details or reach them, like in the case of the map, from this screen. But of course, that is something you could build differently. It's just the approach I want to go with here. Okay, so that is our list of places where we can also view place details. We get there from our list of users because every place is mapped to a user. So we have to tap a user first before we can see the places. Now, what about the other buttons we have there? The off button and the new button up there. Well, let's start with the off button. When we press this off button, I of course, again, want to have my header up there with the same menu options we saw before. But then here, I want to have a form where the user has to enter some data, namely the email, the password, and also any other data we might need. For example, also a button which allows us to pick an image and so on. This all should be here. And then we need a button which allows us to log in, or also switch the login mode so that we can basically toggle between login mode and sign up mode. And this will also affect what we see up there. So when we're in login mode, we of course only have to enter email and password. If we are in sign up mode, we will also need to provide the image and the name of the user and so on. So that's the authentication form, which we only are able to reach if we are not authenticated yet. Now, what about the use case that we are authenticated? Well, then we can, of course, press this new button here in the menu and go to a new page where we also see the good old header, but where we then can create a new place. And that is very similar to the authentication page with totally different fields, but the idea is the same. Here we have input fields to create a new place, also our image picker for the place, and so on. And then, of course, a button to add that place. That is the general idea here. We simply have a page which allows us to create a new place. Of course, when we tap this add button, or when we tap the login button down there, we send a HTTP request to the backend, where we will then basically send or attach all the data we picked here in the form. And then on the backend, we can extract that data and create the user, create the place, and so on. Now, creating a new place is one thing. We also have this edit button here, right? So when we tap this, we also want to go to a new screen. And that should be a screen with the good old header we already know. And on that screen, I also want to see a form, a shorter form though, where we can edit some data, specifically the title and let's say the description of a place. Not image and address, but these two fields should be editable here. So we basically have like a shorter form of that create new place form here. We have a, well, shortened form to update title and description. This is what we could have here. Now, when we click the delete button, I want to open up a modal where we have to confirm the choice and basically have a chance to cancel the deletion process in case we click this button accidentally. Well, and that is my beautiful drawing, which basically lays out the front end of this application. Now, I can guarantee you it will look prettier than what I drew here, but this drawing here, this skeleton, which I sketched out here, basically gives us an idea of the flow of our app and how users can navigate through it. It gives us a rough first idea of the pages and components we will need there, and it basically helps us build the right application, the right React application for the app we want to build in the end. So that's my sketch for the front end. Now let's analyze which data we got in our application and which endpoints we need on the back end. Now we have an idea of how our application should roughly look like. Which data are we going to work with? Well, there are two main entities we heard over and over again in the last lectures. We have users in this application, and of course we have places. Now it's up to you which exact data you want to have on your user model and which exact data you want to have stored in your places. For me, in this demo application I came up with, I want to have users who have 4 key fields or attributes. Every user should have a name, an email address, a password, and also an image. Now, name and image are optional. We'll definitely need email and password in order to implement authentication, which of course requires an email-password combination. Now, for the places, it's also up to you, but there I want to have a title and a description for every place, a human readable address, so basically street name, city name, a location, which is a pair of coordinates, latitude and longitude, and also an image. Now, besides these two standalone entities, it's important to understand that of course they are related. Every user can create multiple places and therefore owns multiple places. And on the other hand, every place belongs to exactly one user. So implementing this relation and updating it correctly will also be a part of the application we're going to build. So we know about our data and how the front end should look like. Before we plan the different routes we want to have on the front end and which pages we need there, let's have a look at the back end. Which API endpoints will we probably need there? Well, since we have two main data models here, user and place, I got two main endpoint areas. Let's say we want to accept requests which reach our backend domain.com/API/users, and then there are a couple of specific routes which all start with API users, specifically /nothing. If a GET request reaches our backend domain/API/users/nothing else, then I want to return a list of all users. We'll need that for the page where we display all users and the number of places they created. If we send a post request to /API/users/signup, then I expect to have data attached which allows us to create a new user, and then after this creation succeeded, also automatically log the user in. And you will learn what logging users in means in the context of a MERN app in the authentication module. When we send a post request to /login, we'll just log the user in. So I expect to have a password and email attached to that request. And then we'll skip the creation part because we assume this user already was created. We just try to log the user in. So these are our user related routes. But of course, we also have places. So let's say for requests which reach our domain /API/places/user/UID, if that's a GET request, then I want to retrieve a list of all places for that given user ID. So the idea here simply is that we are able to get all the specific places a user created. If we get a GET request to just API/places/someplaceID, then I want to get that specific place by that ID. And important, both UID and PID, which have this colon in front of them, are dynamic segments. So what exactly is part of the URL here is up to the front end. This will be interpreted as a user ID or a place ID though. Now, if we send a post request to just API/places/nothing, then I want to create a new place, and I expect that the data which is needed to create a new place is attached to that request. If we send a patch request to /API/places/someplaceID, then we want to update that place by its ID. This request will carry data in its request body as well. It needs to carry the data which we need for updating the place, namely the new title and the new description. And of course, updating is nice, but sometimes we also want to delete a place, and therefore I also want to have a delete route where we accept a delete request targeted at API/places/someplaceID, which will, well, delete that place by its ID. These are the endpoints we need. We have all the CRUD operations in there, we have authentication in there, and we will build them out step by step throughout this course. Now let's have a look at the front end. We already sketched it out, but now let's plan the specific page components we need there. So on the front end, we got a couple of pages, and namely when we open the app, when we just visit this website for the first time, we are on mycoolpage.com/nothing. What should be visible on this starting page? Well, I want to show a list of users there. So this list of users where we can click a user to then be taken to the places of that user. Speaking of that, we need a route, and now these are all front-end routes which are interpreted by React, or to be precise, a library that supports routing in React and which will not be interpreted by our backend. So we also want to have a route there on the front end for some dynamic user ID, which we don't know in advance, /places, which should load all the places for that specific selected user. I also want to have a /authenticate or /auth route, which shows us a page that holds the sign up and login forms between which we can toggle, and also a /places/new route, which shows us a new place form. In addition, we need a /places/someplaceID route, which leads us to the page where we see the update place forms, so where we can enter the new data for a selected place. Now, on the front end, not all pages are visible all the time. The list of users is always reachable, and so is the list of places for a selected user. These are always reachable no matter if we, the visitor of this page, are logged in or not. The only difference is that when we're viewing the list of places, when we're not logged in, or if we are logged in but we didn't create the places we're looking at, we'll not see the edit and delete buttons. We'll only see those if we are logged in and we're the creator of a given place. Now, if we are trying to authenticate, this page should only be reachable if we're currently not authenticated. Because if we are authenticated, it makes no sense to try to log in again. We already are logged in after all. Now, for a new place and update place, it's the opposite. These pages, these front-end routes, should only be reachable by users who are authenticated, so who did log in or who did just sign up. And these will be our front-end pages. Now, you don't need to memorize all of what we walked through in this module. Instead, I hope that this module just helps you plan your next project. We will now go ahead and implement all these different things step by step in the different modules of this course. This is just our general agenda, and with that, we're well prepared to start working on the real code.